Ladies and gentlemen, boys and girls, children of all ages, welcome to the Gyle Show. Please welcome your wickedly talented host, the one, the only, Dr. Gyles and Paul.
Hello again, folks. You know who I am, Dr. Gyles. Last time on the show, we psychologically analyzed 3 different people named Paul. They all died in the ending, but who cares? Today we're looking at a completely new subject, calculus. Ooh. Hey, shut your face. We're going to learn about limits and their application in calculus. Now with me, I have my special assistant, John. John.
Hey, Dr. Gyles!
Oh, not you again. Wait, shouldn't you be dead?
Oh, yeah, about that. Yeah, the gun I actually had never had any bullets in it, so nobody actually died.
Yet I got hurt in my arm. I still have the wounds here. See?
I don't see anything. Dude, I told you have schizophrenia.
Well, now that I'm stuck with you, let's just go learn about limits.
Oh, yeah, by the way, your pen, here it is.
What happened to it?
I may have broken it off stage.
After this show is over, I'm literally going to take this pen and... Oh, I forgot you guys are still in this room. Anyways, let's go to the room of learning.
Isn't that just like a really small, dumb room with a whiteboard in it?
Shut up, you!
Oh, jeez.
Away.
I don't even know anymore.
Here we are. The room of learning.
Don't you mean the room of boring? I hate my life.
No one cares. Anyways, let's start with the basics. Limits are certain areas on a graph where x approaches a specific value. The function that you should write a limit equation. Now, to read this is the limit as x approaches c of f of x equals L.
Oh wow, this is so interesting! Not.
Hey, if you don't like this, then you can just leave.
Fine, I will. Jeez.
Good. I don't even need you anyways. As I was saying, there are 3 different ways that you can solve a limit equation. The first way is drawing out a table. Now, in making a table, you have to choose values that are really close to the number or c that you're solving. So let's start off as an example here. Let's choose the equation y equals sine of x over x. So, and let's say we're trying to find the limit as x approaches 0. Now see, in this equation what you would have to do is you'd have to pick numbers really close to 0 but not 0 exactly, and see what their y values are. So in this instance, we would choose... These are all values really close to 0. And so I'm going to take out my handy-dandy calculator and solve this out for you guys. When I plugged in negative 0.01, I got the following. 0.999. Now I'm going to plug in the next x value here. Oh, the same exact value, 0.999. Now I'm going to plug in these last 2, 0.001. Same thing. And I'm pretty positive that 0.1 would also be the same thing, but let's just be safe and plug it in anyways. And what do you know? 0.999. Now, if you look at all 4 of these values, you can tell that it's really close to the number 1. And because then in this term, that is actually the answer. The limit as x approaches 0 of sine x over x is indeed 1. Now that's how you solve it by using a table. Second method in solving limit equations, I'll show you in 1 minute. So yeah, the second method in solving a limit equation is by graphing the equation and seeing where the value approaches at whatever the x value is. So in this scenario, if we're trying to look for x equals 0, we would look at the graph, look at x equals 0 and see where the y value would be. So I'm going to draw the graph for you guys. Alright, so here's the graph of the equation y equals sine x over x. Now, as you can see, at x equals 0, the y value is at 1. And to double check, you'd have to look at the limit from the left of 0 and from the right of 0. And as you can see, it both goes to 1. So that's how you can tell by graphing that the limit as x approaches 0 is 1 of this equation. The next way to solve a limit equation is by simplifying the equation itself. And, well, you can't really do that in this scenario because there's an x in the denominator, and you can't really simplify that. That's as much as it goes. And you also can't plug in 0 because if you put a 0 on the denominator, the equation is undefined, and that's not going to help you. So there's two certain things that you need to memorize when you look at in the equation y equals sine x over x. I'm about to write them down for you. The first thing you need to memorize is that the limit as x approaches 0 of sine x over x automatically just equals 1. That's just something that you've memorized. That's just plain facts. The second thing that you need to memorize when you're talking about this equation is that the limit as x approaches infinity of sine x over x is equal to 0. These are just two equations that you just have to memorize. Now, next we can talk about piecewise equations. Wait, what's going on?
Oh, hey, Dr. Gyles. I may have just, here you go. I may have just stolen your car keys when you weren't looking, and I just kind of crashed your car into a moving train.
I'm so glad you survived and you just destroyed my $1 million car with a moving train.
Oh, really? I thought you were going to be mad at me.
No, it's sarcasm, you idiot. Just go over there.
Fine.
So here we have a piecewise function graph. As you can see, sometimes there can be a hole inside the graph, but that does not mean that there can't be a limit. In this graph, you can see as it approaches this point from the left and the right, it is the same, which means that there can be a limit there. And in this case, it would be 1. But even though you see this point up here that's solid, it doesn't mean that there can be a limit up here too, because as you can see, the graph isn't approaching this point anywhere. But there's such thing as one-sided limits, and let me show you how to write these ones down. You can have the limit as x approaches a certain value from the left, and to indicate that it's from the left, you put a minus sign right above the c of f of x equals L. And you can do it from the right, so it'll be the limit as x approaches c from the right as f of x equals L. These are the two ways to write one-sided limits, and one-sided limits come into effect where there are jump or infinite discontinuities, because in those scenarios, they're usually always one-sided limits, so either the left or the right. There's never just one full-on limit to it. Now, let's cue to the properties of a limit. Well, I was going to have my special assistant, John, teach this next part, but he's probably dead. So, I'm going to have Paul teach this next part instead. Paul? Oh, I'm sorry. Did I break your concentration?
Actually, yes, I was concentrating on ignoring you.
Just go teach the subject.
Fine, whatever. So, we're going to learn about properties of limits. So, there are a few properties of limits that you should probably know. First, there's the addition or subtraction one. So, let's say I have two functions, okay? I have the limit as x approaches c of, let's say, one of these, say it's 5x, and it could be plus or minus x squared, right? Like, it could be either plus or minus of the situation. What you can do is you can actually separate them out. Hold on, that was a terrible equals sign. I'm sorry. Hate my life. You can actually separate these two out so that you have the limit as x approaches c of 5x, and you put plus or minus in between the limit as x approaches c of x squared. So see, you just separate those out into two separate limits, approaching the same value, plus or minus goes in between. So that is the first property of limits. There are a few more, so bear with me. There is the multiplication one. So say if I have the limit as x approaches c, let's use the same functions to make it easy, of 5x times x squared. I can actually separate those out, just like I did with the addition or subtraction ones, and do the limit as x approaches c of 5x multiplied by the limit as x approaches c of x squared. So you can see, you can do the same thing like you did with the addition or subtraction, but put the times. Pretty interesting stuff, not? The same goes for division. I'm keeping division separate though because it's pretty different. Limit as x approaches c. Once again, we're going to use the same function, but limit as x approaches c of 5x over x squared, right? We have that. You can actually simplify those even further. Now I'm going to write over here because it's kind of a lot of stuff. You can have the limit as x approaches c of 5x divided by the limit as x approaches c of x squared. Now, one thing to notice with this is that you can't have x equal 0 because you have x squared on the denominator. You can't hear either of these cases because if you plug in 0, you get over 0, which is undefined. There's a couple more. There's one called the constant multiple rule. Say I had the limit as x approaches c of 5x. Let's say that. So this would be the k, and that's of course x. What I can actually do is I can put the 5 in front of the limit and have 5 times the limit as x approaches c of x. Now see, you would do this part first and then you just multiply by 5. It's the same thing as doing the limit of 5x. The last property, which is kind of boring, but it involves exponents. So say I had the limit as x approaches c of x squared. Now, you see I have the exponent x squared. I can actually take that and apply it to the whole limit. So that could actually be, in parentheses, the limit as x approaches c of x, and all of that squared. So see, all I did was I took that and applied it to the whole thing, instead of just the function. Yeah, so those are the properties of limits, and yeah. Am I done now?
Whoa. Never, and I mean never, do that again. You are so boring that I actually fell asleep. You will never be a math instructor, let alone an actor.
You take that back!
While Dr. Gyles and Paul solve their personal issues, please listen to this intermission song that gets pretty annoying after 10 seconds.